Today, our topic is on chemistry of catechols. So, generally, catechol means phenyl group which is attached with 2-hydroxy moiety. So, this nucleus is termed as a catechol nucleus. Coming to basic chemistry of this catechol ring, catechol nucleus consisting of phenolic OH groups. That means how many phenolic OH groups are present in catechol nucleus is two phenolic OH groups. Okay, what is the difference between a OH group which is directly attached to benzene ring and OH group is directly attached to alkyl group? That is nothing but a difference between a phenol and alcohol. The main difference between the phenol and alcohol is when OH group is directly attached to sp2 hybridized carbon atom, that OH group will be termed as a phenolic OH group. Here in this case, OH group is directly attached to OH group is directly attached to phenolic. That OH group is nothing but phenolic OH group, which is attached directly with this benzene ring. So this OH group is termed as a phenolic OH. Whereas in alcohol, OH group is attached to alkyl group. So whatever the alkyl group it might may be, the OH group is attached to sp3 hybridized carbon only. But in phenol, OH group is attached to sp2 hybridized carbon. So that is the main difference between phenolic OH and alcoholic OH. So in alcoholic OH, OH group is attached to sp2 hybridized carbon. In alcoholic OH, OH group is attached to sp3 hybridized carbon. So there is the difference between alcohol and a phenol. So what I'm saying right now, this is the statement for this step. So all the carbons are sp2 hybridized carbon. So in this benzene ring, all the carbons are sp2 hybridized because there is a presence of conjugation. So in that case, OH group is directly attached to that carbon, means that is the carbon is having sp2 and the directly attached OH group to that ring is also having sp2 hybridized carbon only. So in that case, that OH group will be treated as an acidic functional group. So when compared to the litmus change, so we are talking about this OH group is acidic in nature. So when compared to litmus, which is acidic OH group, so the acidic litmus paper change was observed from blue litmus was changed to red litmus only. So pH of that phenolic OH group is pH is less than 7 in the pH scale. So if we are considering this OH molecule is acidic, means that H plus ion concentration is obviously greater than OH minus ion concentration. So this statement is derived from this pH less than 7 statement only. Okay, so coming to the acidic nature of this functional group. So we are saying that each and every carbon in this phenyl ring is having sp2 hybridized carbon. So when we are measuring the acidic strength, means so we have to know the percentage of S character as well as the percentage of P character also. So in this, one S atom as well as two P atoms, two P atoms are there. Overall atoms are total or summation of all atoms are 3. So one sp S atom as well as overall atoms are 3. So 1 divided by 3 into 100, that will indicate 33.33%. So coming to P percent, how we will calculate P character, means how many P orbitals are there? 2. And overall, how many orbitals are 3, which is divided by, which is multiplied into 100, that will give 66%. So we are talking the acidic strength regarding this one, means so we have known a relationship, that is acidic strength is directly proportional to percentage of S character. So when compared to P character, the acidic strength is inversely proportional. That means whenever the acidic character increases, whenever the S character percentage of S character is increases, the acidic strength of that particular compound will also increases. Whenever the percentage of P character is increases means the acidic strength of that particular compound will get decreases. So this is direct relation and this is inverse relation. So coming to qualitative analysis or qualitative identification of this phenolic group. So these phenolic groups are present in a number of compounds. So like catechol, resorcinol, pyrogalol. So all these compounds is having phenolic moiety only, and the basic phenol is having also a phenolic moiety only. So all these are the identification test for the identification of phenolic moiety in the given sample. So all these are the visible identification method, simply a qualitative analysis. Okay, qualitative analysis by just adding the reagent to the sample, color identification or color change will be takes place in the test tube. So based on the color change, so what is the color change? So what are the reagent we are used to perform a specific test? So all these are very much essential for a GPAT competitive examination. So these are the identification test for phenolic functional group in the compound. So coming to test, first test is neutral ferric chloride test, that is nothing but neutral FeCl3 test. Second test is Lieberman's test. Third test is phenolphthalein dye test, and fourth test is bromination test. Coming to the reagent that are used in neutral FeCl3 is ferric chloride solution. Just simply taking a test tube, to the test tube sample, that sample is nothing but phenolic containing um, sample, whether it may be catechol or resorcinol or pyrogalol, whatever the compound it might may be. So the sample containing, I mean the test tube containing any one of this sample. So to this sample we are adding ferric chloride solution. Then by with your eyes only visual identification, justly by adding ferric chloride to that phenolic sample means it will changes blue color or green color. So this is the color indication. If blue or green color is present, it means then the sample is containing phenolic OH group. Coming to Lieberman's test. So these are the reagent: sodium nitrate plus sulfuric acid. So sulfuric acid is nothing but a king of chemicals. Okay, sulfuric acid is nothing but a king of chemicals. So and also act as a strong dehydrating agent also, which is also nothing but a strong acid also. So when these two reagents are mixed with our sample present in the test tube, then the color change is from initially it is blue in color. After some more time after adding the reagent, it will get converted to green color. So coming to phthalic anhydride or phenolphthalein test or phenolphthalein dye test, this test name is phthalic anhydride. Anhydride means whenever anhydride is a derivative of acid. Whenever we take an acid, so removal of water molecule from that acid, that will form anhydride form. So anhydride means without having any water molecules. So phthalic anhydride plus H2SO4. So these are the two reagents. These two reagents are mixed with our phenolic sample. Then initially it will pink in color. After it will changes to colorless in the acidic nature. So last test is bromination test. So reagent used is bromine water. Simple, this is an electrophilic reaction. So whenever bromine uh, is added to the phenolic containing sample, it will form a brown precipitate. So the precipitate will be formed at the bottom of the test tube only. So that is white in color. So all these are the identification tests which are used for the qualitative estimation or qualitative analysis of phenolic containing compounds in our sample. Next, coming to catechol connectivity in medicinal chemistry. So what is the purpose of catechol? Uh, what is the use in medicinal chemistry? So all this discussed in this slide only. So in medicinal chemistry, catechol is the basic nucleus present in catecholamines. You are very well known with the sympathetic nervous system or adrenergic nervous system. So catecholamines, neurotransmitters, belongs to adrenergic receptors or sympathetomimetic agents. So that are mimic the actions of sympathetic system. So examples of catecholamines are adrenaline, non-adrenaline, dopamine. So these are the structures of adrenaline, non-adrenaline as well as dopamine. See, in adrenaline, this is the benzene ring, and these are the two OH groups. One, two. First position having OH group, second position is having another OH group. This is third, fourth, and this is fifth. And this is the secondary alcoholic OH group. This is the ethyl side chain. Along with this side chain, secondary amine with the terminal methyl group is there. So we are assume or we are draw a structure of adrenaline means. So first of all, we have to memorize the basic nucleus. So what is the basic nucleus present in the adrenaline is catecholamine or phenol with another OH group, or it will be also known as dihydroxybenzene with a secondary alcoholic group as well as a secondary amine group. So this is catechol dihydroxybenzene with secondary alcohol as well as secondary amine structure. When compared to non-adrenaline, non-adrenaline also known as norepinephrine. So in this, the basic nucleus is same, catechol, along with secondary alcohol that is also same. So when compared to adrenaline and non-adrenaline, in adrenaline, secondary amine is there. Okay. In non-adrenaline, primary amine is there. Primary, that is nothing but aliphatic. Primary aliphatic, this is secondary aliphatic. So that is the major difference between adrenaline as well as non-adrenaline. When compared to dopamine, in dopamine simply there is a catechol with ethylamine. Catechol with ethylamine side chain is there. So this is the chemistry. This is the structure of those nucleases, and uh, these are the mnemonics, or these are the what is that steps how to memorize or how to draw a structure. So based upon what all these will be in this format only. So adrenal cortex or adrenal cortex is not adrenal medulla. From adrenal medulla only these catecholamines are secreted. Catecholamines is secreted by chromaffin cells. Okay, adrenergic or sympathetic receptors belongs to G protein coupled receptors category. Adrenergic receptors categorized into two types. One is alpha receptors and another one is beta receptors. Alpha receptors is having alpha 1 and alpha 2 receptors, and beta 1 is having beta 1, beta 2, and beta 3 receptors. So coming to applications, so phenolic moiety in the catecholic nucleus act as an antioxidant activity. So polyphenolic compounds or secondary metabolites of the plants like flavonoid and flavonoid derivatives consisting of phenolic OH. Okay, and these phenolic OH in the polyphenolic compounds are also act as an antioxidant activity, and the phenolic moieties are also act as a disinfectant activity. So all these are regarding a catechol chemistry. Okay, thank you.